Okay, so hi and welcome. Can you hear me?
Yes, I hear you and I can speak.
Okay, so can you hear me now properly? Yeah.
Yes, I hear
Okay.
you.
Okay. So how are you?
Fine, thanks. The same work, and yeah, I try to learn everything what we learned in our classes.
Okay, great. Okay. So I hope you already get the recorded video class for the previous class. You get the recorded video class. Did you get it?
Uh,
Third number of class.
I can't remember. You didn't send me a link in Telegram.
Okay, so I'll send you the for the today's class and also both of class I will send you at the same time, so you can easily
Okay.
get the access, no problem. Okay. Okay,
Okay.
so basically today is our I think it's the fourth number of class, and basically today I
Yes.
try to discuss about the supervised and unsupervised classification using RStudio. How we can easily make the land use land cover classification, mainly supervised and unsupervised, using RStudio in the R programming language. Okay,
Okay,
so yeah,
I have just one question.
yeah, please.
Do you resolve how we can directly work with Google Earth Engine R and Google Earth
Yeah.
R?
So okay, so we have the another part about that, how you can easily connect the
Okay,
R Studio with Google Earth Engine and also do for the
okay,
lot of analysis also with that. So it's our another days I also try to cover this part for the connecting the
okay,
Google Earth Engine with R and make the different types of remote sensing analysis. Okay.
okay.
Okay,
Thank you.
so basically for today's class, I discuss about that how we can easily use the R programming language. So mainly R have a different types of library or different types of package. So using this package, we can easily work for the different types of remote sensing analysis, such as we can easily implement the random forest classifier or classification regression trees classifier or different types of supervised and unsupervised machine learning method we can easily implement using the R package. Okay, and different types of analysis. So let's go how we can easily do that using the R programming language for the land use land cover classification. Then we also for the another day also try to discuss about the Google Earth Engine with R programming language. Okay, so let's go.
Okay,
So now can you see my screen?
just a moment.
Yeah, so now can you see my
Yes,
screen? Yeah. Okay.
yes, yes.
Okay. So okay. So hi and welcome to the remote sensing analysis with R programming language. So basically today I will try to discuss about that how we can easily implement the supervised and unsupervised land use land cover classification using R Studio, mainly R programming language, and also different types of algorithm how we can easily apply in here. So here you can see this is the one kind of land use land cover classification map. Mainly
Decision
it's
tree.
created the wetland, then cultivated land, herbaceous, shrubland, forest, barren land, urban land, and also water. Okay, it classified. And in this time we are just use here the R Studio, R package, R different types of libraries for the creating the decision trees, all of those things. As well as also you can see this is the another thing is the unsupervised classification based on NDVI. So based on NDVI, we make the unsupervised classification and also classify
Oh,
this type of feature: water body, vegetation, build-up area, barren land, okay, prop land. We can classify it in
and
here. Yeah.
for unsupervised classification, we don't use any training samples.
Yeah.
Yes.
It's just we can take the
Okay.
pixel value, but we did not take any types of training point or training sample. Okay, and mainly
Yes.
we take the training point for this supervised classification. Okay, and unsupervised classification, we did not take any types of training point or training data. We did not take. Just we take the spectral signature. We did take the only for the pixel value. Okay, but we did not select. This is the water body. This is the build-up area. This is the barren land. This is the cropland. So this type of selective training point we did not set for the unsupervised classification. Okay, so we discussed a lot of things about that. So first of all, unsupervised classification in R. So unsupervised classification, it's mainly the machine learning, and this is the unsupervised machine learning. And unsupervised machine learning, its definition is that when you do the unsupervised classification, you did not take any types of training point or training data set. We did not take any types of training data set for each classes. So mainly we are use this algorithm. It's called the k-means algorithm. Okay, so it's the algorithm about the k-means algorithm, and this k-means algorithm mainly find out the similarities pixel value and make the classification. Suppose when I apply the k-means algorithm, it's an algorithm mainly unsupervised classification. There are a lot of algorithm, but k-means algorithm we are use and make the unsupervised classification. And mainly this k-means algorithm, it create the all of those similar pixel value and make the classification. Suppose all of those water pixel value, it has a similar or similar characteristics, all of those pixel value, and make the classification. And its unsupervised classification, we use the reflectance data, but we don't supply any response data. Okay, we can only use the reflectance data. Mainly we can take only for the, we use the pixel value, but we don't supply any types of training point, training data set. We did not supply any types of training data set or response data. And it mainly useful when you don't have much prior knowledge of your study area. Suppose you have a study area and you don't know what is the feature on this study area. You don't have the much knowledge about the study area. Then we can easily apply the unsupervised classification method, and we can easily classify our land use land cover without taking any types of training data. And this algorithm group pixel with the similar spectral characteristics into a group. Okay, so mainly this algorithm, all of those group pixel with similar spectral characteristics. Suppose when I apply the k-means algorithm, this k-means algorithm create the group of pixel. Okay, and this group of pixel have the similar spectral characteristics and make a group. So now you can see the example about that. Suppose in this time here you can see the Landsat NDVI. So basically we can take the reflectance data. It can be different types of band combination. In this time, as a reflectance data, I use here the NDVI reflectance value or NDVI pixel value. Okay, so in this time for the reflectance data, I take the pixel value of NDVI. Okay, so based on NDVI band, I create this unsupervised classification and classified the water body, build-up area, barren land, cropland. Okay, all of those things we try to classify it. So this is the one example about that. In unsupervised classification, we just use here the reflectance value, but we did not supply any types of training point or training data set. As well as supervised classification. What is the supervised classification? Mainly supervised classification, when you want to do the supervised classification, you must take the training point. You have considered this is the water body, this is the vegetation, this is the build-up area, this is the barren land, this is the cropland. So this type of training point you need to supply on your data set, and then it extract the pixel value from a specific data set. Suppose it extract the pixel value from the water point, it extract the pixel value from the build-up area, it extract the pixel value from the barren land. It extract the different pixel value extract from the different feature or different land use land cover classes. So in this time we just talk about the cart and random forest. So cart and random forest, it is the method or algorithm for the supervised classification. CART is the classification and regression trees, and random forest is the another algorithm. So these two type of algorithm, how we can easily use in our programming language and make the land use land cover classification map. I also try to discuss in this time CART and random forest. And basically in supervised classification, we have prior knowledge about the some land cover types through, for example, fieldwork or reference special data. So in this time, when you make the land use land cover classification, supervised classification, you have to know some prior knowledge about the land cover types for the study area. Suppose for your study area, you have to know some knowledge. Suppose this area, what types of land cover land use is available. So this type of knowledge you have to know first when you want to make a supervised classification map. So as well as you can also use some reference special data. Suppose you can use the Moody's land use land cover data or any types of data as a reference. Okay, as a reference we can use any data as a reference data, and it's need only for the supervised classification. But when you want to do for the unsupervised, there don't know any types of reference special data, or you have not prior knowledge about the for your land use land cover type for your study area, there is no problem. But when you want to do for the supervised classification, we must know about the some knowledge for your land cover types in your study area, and also you have some fieldwork data. Suppose you can go to the field and take the pixel, take the training point at a GPS location, and you have also some reference special data, then you can easily use it for the supervised classification. So mainly when you want to do for the supervised classification, we have to follow some steps. This step is that first of all, you generate the sample site based on a reference raster. Okay, so you have to take the some sample. Mainly you have to take the some training point. You have to take the some training sample sites based on a reference raster. Reference raster means that your reference data set for the land use land cover reference data set, as well as you extract the cell values from Landsat data for the sample site. All of those sample sites, you have to extract the cell value. Mainly it's the pixel value. Cell value means the pixel value. Suppose you want to use the Landsat data, so all of those pixel value for Landsat data you have to extract from the sample sites or training point, and then train the classifier using the training sample. You have to train the classifier using the training sample, and then classify the Landsat data using the trained model. And after evaluate the accuracy of the model, what is the accuracy of your land use land cover model, or we have to also need to check about that. So this is the step when you want to make the land use land cover classification using supervised machine learning. First of all, generate the sample based on the reference raster, extract the cell values from the Landsat data for the sample site, train the classifier using train sample, classify the Landsat data using the train model, and then evaluate the accuracy of the model. Okay.
Yes, I have a questions.
Yeah.
There is some rule how many training samples we need to create for each class. For example, 10, 15, 100 samples.
Okay.
How many samples
So
we
basically, it's depend on your region of interest. Suppose when you want to work for the big region, then we have also take the more sample. And when you want to work for the small region, then 30 or 50 number of training point is the okay for the small region. But when you want to whole area, suppose you want to make the land use land cover classification map for the whole country boundary of Bangladesh or whole country boundary of Ukraine, then you have to take the training point more than 100. Okay, otherwise 50 is the okay, there is no problem. Okay, and it also depend on our accuracy. Suppose you can check your accuracy is not good, then you have also need to increase the training sample. Suppose I check the accuracy is not perfect, then I also need to increase the training sample and then evaluate the accuracy again and check the model.
We create separately training samples, and after we create some validation samples. Yes.
Yes. Yes.
And for validation samples, we need to create the same count of samples as for
Yeah.
training samples, or
You
no?
can you can also use the same. Okay, it's there not difference about that. If you want to same or also they take the large that than the point sample, it also no problem about that. Okay, so just try to take the training point or sample point more than 50 for the small region and big region more than 100.
Okay, thank you.
Okay. Okay, so now you can see card. So mainly card, how it will be work. So mainly card create this type of classification tree. Okay, so it create this type of classification tree and check each pixel value. Okay, suppose you can see here, suppose 2 1 2 3 4 5 6 7 8 9. So you can see, suppose this is the one kind of class. Suppose one is a suppose water, two is a build up area, three is a suppose cropland, four is a suppose build up area. Okay, suppose this type of cropland. So mainly card classification, it check about the pixel value. Suppose short wave infrared one less than 0.07371, then it will be suppose 1. Or if there is the no, then what the condition? Then check the another pixel value. Blue is the greater than equal, then what happened? Also check about that another. So it check again and again, and final result. Final result, in this time I can get the 1. So this is the 1. This is the 2 class. This is the 3 class. This is the 4 class. So basically cart is mainly create this type of classification tree and check the result. Okay, so we try to practically, then it's better. So also you can see this is the final result about that. We can just create the land use land cover classification using the cart and then check the result about that. So let's go our code editor. We try to discuss all of those things practically, then it's better. Just I open. Okay, just I open my okay, art studio. Okay, so previous class we also discussed from here. Just we show you that how we can easily create the NDVI. Okay, so for that, first of all, you have to import your raster library. Just simply import, and then import the all of those band. So mainly in this time here I stored the from 1 to 11 all of those band. We simply imported in here, and after that we make the stack. Stack means that all of those band we join together. Okay, all of those band join together using the stack function. And after that we can make the Landsat true color composite, mainly red band, green band, and blue band using the true color composite, as well as also false color composite, near infrared red and green. We make the false color composite. And after that, here we create a function. Okay, so basically it's a function. In this function, we take a variable name vi, and then use this symbol. It's basically equal. Okay, then define here the function keyword, and then put the element name img, k, and I. So then I define what is the img, what is the k, and what is the I. So then I simply take a variable bk, img set the k, and bi equal to img I. Then I simply put the equation bk minus bi divided by bk plus bi. Okay, then return it as a vi. Okay, so now this is my function. Okay, so in this time, this function I need to apply for this image, this Landsat. Okay, so I simply copy the Landsat and paste here, and you can see this is the vi. Mainly this is my function variable name. It's my function variable name vi. Okay, and then put the Landsat and define here the band name near infrared and red. Okay, so now it's calculated this Landsat near infrared and red for this equation, because this function is stored in this variable vi. So I simply call the vi and put here the Landsat image. From the Landsat I take only for the near infrared and red band b5 and b4. Okay, so now I display the result. So just I simply run the code again. So run, and also run this code. Okay, so after that we simply plot this NDVI simply plot and put the title name is the Landsat NDVI. So click the run. So now it show the result about the NDVI. So this is the one way for creating the NDVI. And another way is that you can take, suppose this is the another approach. So take the variable name. Suppose I take the variable name is the VI2. In this variable, I just simply stored a function. So take the function keyword and take the element, suppose X and Y. Okay. Then use at the curly bracket. In this curly bracket, just mention my equation X minus Y divided by X plus Y. Okay. So after that, take the another variable NDVI2 and then equal sign. In this time, we have to use the overlay function. Overlay length set. Take the 5 comma length set 4. Then fun, it's a function. Fun function equal to this variable name. Okay. So it's another approach. Just you also try to then create this any types of indices using the Art Studio. It's the overlay. Just in this time, it create the another, but it's the same approach. We can get the same result, but we apply to the another syntax for write this function. Okay. As well as you also discuss about that histogram of NDVI. Suppose I want to create the histogram, all of those pixel value one by one. So for that we use here the hist function. So mainly it create the histogram, and we put here the title, X label, Y label, title, color. Okay, then we can simply show the result. You can see it create the histogram of NDVI result. So it create the histogram of NDVI result. Okay, so basically 0.2. Suppose how much pixel we can get in here. So it is a larger. So basically in this time you can see here the negative pixel value identify there is the no vegetation, and highly positive value identify about the vegetation. Okay, suppose 0. Greater than 0.4 or greater than 0.5, all of those pixel value greater than 0.4 or greater than 0.5, all of those pixel value identify about the vegetation, and all of those negative pixel will identify about that it's not a vegetation. It can be water, it can be barren or rock, this type of feature. Okay, so now from
barren and raw can we have negative NDVI? Yes.
Yeah, negative NDVI, mainly negative. It's identify about that water pixel value or also barren land.
Okay.
Okay. So now from this histogram, suppose from this histogram I want to make only for the vegetation map. Okay. Suppose from this NDV from this histogram, I take all of those pixel value greater than 0.4. So all of those pixel value greater than 0.4, I consider as a vegetation. So then I can get the vegetation map. Okay. So now I show you that process, how we can easily. So it's called the thresholding. Okay. Thresholding mainly when you want to extract only for the specific pixel value. Suppose I need only for this pixel value, which is the greater than 0.4. Okay, and which means that vegetation greater than 0.4, all of those pixels will identify about the vegetation. Okay, suppose I also pull out the map. You can see. Suppose this is the map, NDVI map. From this NDVI map, I want to extract only for those pixel value, which value is the greater than 0.4. Okay, so for doing this type of analysis, we have to apply the thresholding. It's called the thresholding. So using the thresholding, we can select any specific pixel value. So for that, take a variable. Suppose I put the variable name is the suppose vegetation. You can put any variable name. I take the variable vegetation, and we have to use the function. This function called the reclassify. Reclassify. Okay. Mainly this reclassify function need when you want to apply the thresholding. So I call the reclassify. I want to reclassify this NDVI map. Okay. This NDVI map I want to reclassify. So for that, I simply copy this NDVI. So I simply copy this variable name because this map is stored in this variable. Okay, and paste here. Okay, and then what can I do? In this time I need only for those pixel value greater than NDVI values greater than 0.4. It definitely vegetation. I want to show only for this pixel value greater than 0.4. So for that, I use a function. It's called the cbind function. Okay. Mainly the cbind function, it create the specific pixel value. In the cbind, I put here that negative info in and then put at the 0.4 and then use at the in A. Okay, so it's lower, it's uppercase I.
And A, it means that there are no any value, yes?
Yes. Yeah. In this time, you can see when I run the code, okay, it will be working. And now I want to plot only for the vegetation map. We set the greater than 0.4. So just use at the plot the vegetation, only for the vegetation. Simply copy and paste. And I also put the title. For the title, we use a function. It's called the main. Okay. So mainly it's main. We have to define here the title. Suppose I put the title is that vegetation map. Okay. Then I put the title. So now just plot that. So in this time, it create only for those pixel which are greater than 0.4. Okay. Only for the 0.4. And other pixel you
can I ask you?
Yeah, please.
This function vegetation, it means include NA or uninclude NA? Yes. This include NA or no?
No.
Okay.
Yeah.
No.
Yeah. Suppose in this time I simply put at the in this time 0. So I'm going to show only for the 0.6. All of those things 0.6. Click to the run. You can see in this time we can get more dense vegetation. Also you can see. So this place is the 0.6 greater than 0.6 pixel value. Suppose I also put at the suppose 0.7, then I also get the more dense vegetation. So just click to the run and also plot that. You can see we also get the more dense vegetation about that. This vegetation is the 0.6. Suppose I check about the 0.8. So we are using at the different types of pixel and check our map. Different types of map. You can see, click to the run again. In this time we can get this map 0.8 greater than 0.8 all of those pixel value, and it's the mostly dense vegetation, mostly dense, because for the NDVI it will be start from the 0.5, but when I move to the more positive value, increase the positive value, then it will be also dense vegetation. Okay, mainly 0.5 it consider all of those vegetation. It can be grassland, it can be shrubland, it can be dense vegetation, it can be cropland, all of those things including in the 0.5 or 0.4 greater than 0.4. So in this time you can see we can get this type of map. So it including all of those vegetation without barren land, without water, without other types of feature. All of those vegetation we can consider in here. Okay, without other types of feature such as water body, barren land, okay, or other types of feature is not including in here, only for the vegetation.
Very good, yes, thank you.
Okay, so now in this time, suppose you want to display only for that barren land, you want to display only for the barren land or water body or barren land or only for the land. So in this time we have set the another suppose in this time I want to create the another thresholding for suppose I also write the comment, suppose 0.25 to 0.3. okay, so between this range, because 0.25 to 0.3, between this range we can get the barren land. Okay, barren land, it's not a water, basically water is the negative pixel value. In this time I take the 0.25 to 0.3, it will be just a barren land or barren land or fallow land in the feature. So in this time I apply the 0.25 to 0.3 and make the barren land. I make the show the barren land map from the vegetation. Okay, basically you can see here I just simply show the result about that. Suppose this is our main NDVI map. This is main NDVI map. From this main NDVI map I just display only for the barren land. Okay, and I use this type of range 0.25 to 0.3. So using this thresholding I just find out where the barren land is available. Okay, so let's go about that, how we can easily do that. So for that, take a variable. Suppose I put the variable name is the land. You can put any variable name. In this land variable, I also need to use here the reclassify function, because in this time I want to put the range 0.25 to 0.3. So just use a function reclassify, reclassify this NDVI map, and this NDVI map is stored in this variable NDVI2. Just I simply copy and paste here, same variable. Okay. In this time, I just put here the range about that. So put a function, this function called the cbind. If you want, you can use here the cbind, or if you want, you can also use here the only for the C. There is no problem. Cbind or C, there's the same. There is no problem. Then put here the inf, and then use here the 0.25. Then use here the na, and also put here the another thing is that put here the 0.25 comma 0.3 comma use here the 1 0.3 comma inf. Okay, then put here that na. So in this time, what happened, you can see in this time inf 0.25 na and 0.25 to 0.3, we make a one class only for the show the one single class. Okay, in this time, using this threshold, basically using this range, I mention a one class. I mention a one class only for the land. So just I use at the one. Suppose and after that, you also try to show you the, suppose I use at the different types of classes using the different thresholding range. Then we use at the 1, 2, 3, 4. So in this time 0.25 to 0.3, I make a one class. So use at the one only for the land. In this time it's showing. So use at the one. So now display the result. Suppose I simply plot that. So use at the plot this land. Just use at the plot and land. And after that, I put this main function main and put here the, suppose it is a land. Just I put the land. So now first of all run the code again. Okay, also plot that. Okay, in this time, this map is showing only for the land or barren land without vegetation. It's showing only for the barren land. It's showing only for the land area. This range 0.25 to 0.3. So how I can define it? You can see INF 0.25 NA, then 0.25 to 0.3. I make a one class for land. Then 0.3 is a pixel value, my maximum pixel value, and then INF NA. Also now it's showing the result about that. Yeah.
Mijan, why we have near our map some thresholding from 1 to 0.999? For example, the minimum 0.999, a maximum 1. Why we have this thresholding and no
Okay. So what is the minimum value about that? Minimum value is that 0.9.
Yeah.
And maximum value?
1. But
okay. Yeah. So for that you can simply change. Yeah.
Okay.
Just put here, suppose put here the 0.9. Also put here the 0.9, and it will be just 1. It's our pixel value about that, and it's the class about that. And also put here the 1. So in this time you can see what happened. Just plot that. Okay, so in this time for this region 1 and 0.9, okay, 0.9 and 1. So it's very similar. 0.9 and 0.1 is very similar only for the 0.1. So this 0.1 pixel value is not available. So that's why in this time it's not showing the result, any types of result in here. Okay.
But I would like to ask you that in our map, the first map, when thresholding from 0.25 to 0.3, we have in our, you saw You see, in our map, we have thresholding like legend from 0999 minimum to 1. Why we have this legend?
Okay, so in this time you can see, yeah, okay, I understand. Yeah. So we can define it using the legend, and we can easily display the result.
Okay. Sorry, you want to explain?
Okay.
Yeah,
Okay,
sorry.
okay. Okay. So in this time you can see here, in this time it's just showing only for the result between these friends 0.25 to 0.33. And now I want to check it. Oh, what is the pixel value I can get in here? So in this time I also add the another layer. In this time I take the another layer for that, suppose false color composite. Okay, this false color composite or a true color composite. This layer I want to overlay on this image, overlay on this pixel value. Okay, so for that I simply overlay, then I can easily find out what's the pixel value about that. So it is the land or not, we can check it from the satellite images. So for that, how I can overlay? For the overlay, I can simply use here the plot. In this time I plot the false color composite, so that's why I use here the RGB. Okay, plot RGB. So mainly when I want to display the false color composite or true color composite, we have to use the function plot RGB. Okay, so after that I simply call this, suppose I call this Landsat RGB, and paste, and then I set here R equal 1, then green equal 2, B equal 3, and then put here, suppose I put here the axis equal true, and then also put here the stress. Basically we are using lean. Okay, for the showing the result, lean is the best, so use here the lean, LI and lean. And I will also mention about the title, so use here the main, and title will be just put here the title. Suppose I put the suppose Landsat false color. After that in this time, after doing that, just print that. So just we simply plot okay, it added this color. I again plot that. Okay, and now I want to just overlay this 0.25 to 0.3, this pixel will simply overlay. So just use here the plot function again, and then call the land, and apply here add equal, and put the legend. In this time, suppose I put here the legend equal suppose false, and now show the result. Okay. In this time you can see display the result. In this time we can get this type of pixel value which are less 0.25 to 0.3. So basically in this time we can find out this is the barren land in the satellite images, and it also overlay with our false color composite in here.
And we can change color, for example, in red, from
Yes.
yellow in red.
Yes.
Okay.
And now in this time we can also create the classes for different amount of vegetation presence. Suppose I can make the classes. Suppose I want to create the total 5 class from the vegetation classes. Suppose class 1, 2, 3, 4, 5. Suppose 1 is the low vegetation, then sparse vegetation, high vegetation, very high vegetation. So this we can also create the classes for different amount of vegetation presence. So for that, how we can do for the use the different types of classes. At the same time, I create the total 5 class for NDVI. So for that, we have to take a variable. Suppose put the variable name is that, suppose vegetation C, and then use at the reclassify, and then call this NDVI map. You can see our NDVI map in here. So these are NDVI map. Simply copy and paste. Okay. So after that, in this time we make the class. Okay. So for making the class, suppose in this time 0.25 is the one class. 0.25 to 0.3, it is a second class. Suppose 0.3 to 0.4, it is a third class. Suppose 0.4 to 0.5, it is a fourth number of class, and 0.5 greater than 0.5, it is a fifth number of class. Okay, we use the different types of pixel range and then divide the different classes. So first of all, just use at the C or C bind, use at the C. First of all, use at the negative less than, mainly I, N, F, and put here the suppose 0.25. So 0.25, I define a one class. So use at the one. After that, use at the 0.25 to 0.3. 0.3, I define it second number of class. It is a second class. After that, I also take the another thing, suppose 0.2 to 0.25. Then put here suppose 0.3 to 0.4. It's a third class. Okay, third number of class. I define it. After that, I take the another thing. Suppose after 0.4, I put here the suppose 0.4 to 0.5. I define it four number of class. So use at the 4. And finally define here the 0.5 greater than all of those pixel value which are greater than 0.5, I consider as a fifth number of class. Okay, so you can see how I reclassify all of those pixel value from NDVI. So less than 0.25, so use at the negative info 0.25, make a one class. All of those negative 0.25, less than 0.25, all of those I make a one class. And 0.25 to 0.3, create the second number of class. 0.3 to 0.4, create the third number of class. 0.4 to 0.5, create the fourth number of class. And all of those pixel value which are greater than 0.5, make the fifth number of class. Okay, so now I just try to show you that how we can easily make the map and also show the result, and also add the legend. For each classes, I use add the different legend. So one, it's showing the another color. Two, it's showing the another color. Third number of class showing the another color. Okay, so then we can easily identify for the different different classes of NDVI. So just use at the plot, and I want to plot this. Simply copy and paste. Okay, so after that, just use at the COL color, use at the REV, and then define it a ready-made color about that train, TRRAIN, train dot colors, here 4. After that, just simply make a title about them. Just use at the main and put the title. Suppose I put the title is that NDVI map, NDVI classification. Just put NDVI classification. So now click to the run this code, and also what is the problem. Okay, you have to use at the comma. Okay, use at the comma. So now click to the run again and also plot that. I run the code again. but it's very small. Just a minute. It's showing the small because we are also mentioned about the code. Just a minute. So I run the code, all of those code again, and then check the final result. Okay, so now it's also increasing. Okay, so now we can get the result. You can see with the legend in here, NDVI classification map, and it's showing that you can see it's the one.
Without water.
Yeah, and then also you can see this is another class, also another class, and also another class. So total 5 class. So according to this threshold, we can just simply make the total 5 class of NDVI. So 0.25 less than 0.25. Also you can see 0.25 to 0.3. This is the second class. 0.3 to 0.4. It is the third class. So after that 0.4 to 0.5 is the fourth number of class. And get at then 0.5. It is the fifth number of class. And make this type of classification map in RStudio. Yes.
Wow, very good. How we can add class water with negative value? We can do this or no?
Yeah, we can also do it. Suppose you can put here the suppose greater than, suppose you can make the class for 0 greater than all of 0. Okay, greater than less than 0. Less than 0 means that negative. Then we can get the water also.
Okay. Mm.
So
Yes, now we
basically,
have water.
yeah. So now using this process, we can easily classify for the NDVI, and from that we can easily export our map as the image or TIFF format about that. Okay. So basically, in this time we discuss. Yeah. Please.
Mijan, I noted that when I export the map,
Yes.
this map have a very bad resolution. Because
Okay.
when I create map in ArcGIS after Google Earth Engine, I have very good resolution, and after R, my resolution for map not good.
Okay.
Why?
Okay, so for that we have also, okay, so basically this type of raster image from the R, we can use the another approach for downloading without the export. In this time, you can say when I export it from here, then it's not a provide the good resolution. And we can
Yeah.
also just another way is that we can also increasing the resolution from here. Suppose this is JPG format, and also the TIFF format also available JPG, and also increasing the width and height. Okay, this is not good. Yeah.
Mhm. Okay, thank you.
Just simply increasing this resolution from here. You can simply increasing the width and height. Then it also bigger. This size also bigger, and then we can easily get the better map from here. Suppose you can put here the resolution such as 1000 width and height such as suppose this height.
Okay.
As well as also you can see this is another map. I also export it from here, increasing the height. We can get the very good resolution from here.
Yes.
And it also possible you can also suppose from here you can see there the another option for export the TIFF images. You can see TIFF images. Suppose you can simply download the TIFF image, and this TIFF image you can easily use in the ArcMap software. for creating. Suppose in this time you can see it's not clipping any region. Okay, so you can simply download the tip image from here, and this tip image you can also use in the ArcMap software and clip for your specific study area, and then you can make the map for your specific region using these tip images. Okay, so it also provides the tip image about. Oh. So this is the process for the vegetation analysis, and also make the vegetation map. As well as we can also calculate the same number of principal component as the number of the input bands. The first principal component PC explain the largest percentage of the variance, explain the additional variance and the decreasing the order. Okay. So we are also create this type of plot. So mainly this plot it's showing the result for that PCA. Okay, so PCA means that in this time we talk about the PCA. PCA means that principal component. It explain the largest percentage of variance, and other principal components explain the additional variance in the decreasing the order. Okay, so for that PCA, we can simply use a function. Suppose you can use at the set seed 1, and then suppose take a SR, take a variable SR, and use at the sample random. In this time I call the Landsat image. So I already create the Landsat composite. You can see Landsat. Simply copy the Landsat and then paste here Landsat. Okay, and here I put the sample. Suppose 10,000 sample. 10,000. I simply put the Landsat from take the 10,000 training point. Okay, from the Landsat you take the 10,000. So now I plot that. So use at the plot is SR. Okay, which include stored the Landsat 10,000 sample SR, this variable, and from here we just extract the near infrared band and red band. So put here the C and mention about the bands such as 4 and 5. Okay, and then mention about the title. So use here the main and put the title such as near red. Suppose near red plot. So in this time whatever you can see, click the run. Okay, so now it's create this type of chart near red plot. This known as the vegetation and soil line plot. Okay, so it's also called this known as the vegetation and soil line plot. Just I only plot this. Okay, so this
Very interesting.
yeah, so this is the known as the vegetation and soil line plot, same as the scatter plot in the earlier section we talked about that. So in this time you can see it's showing this type of result about the B4 and B5 scatter plot. We can get this type of plot. So this it's called the vegetation and soil line plot, and we can also extract the information for the principal component. So different types of value, such as we can simply extract the value. You can see for that all of those pixel value. So for that just use a variable of PCA. In this variable just take a variable PR compute. Mainly it's a for the compute. So compute, I want to compute the SR. SR mainly it stored the Landsat 10,000 point. Okay, it take the Landsat from the 10,000 point SR, and then put here the scale as a true. So use here the true. So now just print the PCA. This variable simply print PCA. Then this time it get all of those pixel value about that.
10,000
10,000
10,000
point. Yes.
Oh.
And we also get the standard deviation, the value about that.
What does mean PC1, PC2, PC3, PC4?
Yeah. Also you can see the PC5, PC6, PC7, PC8, PC9, PC10, PC11. So mainly it is a total 11 band we can get in here.
Okay.
Okay. So for each band, what is the correlation with that? It's showing about that for each band. Principal component 1 for the principal component 1, it's mean for the B1 band. Principal component 2, it's for that B2 band. Principal component 3 is for the B3 band. So it create all of those principal component, and you can easily get the result as a plot. So just you can simply make the plot, then we can get the better.
This is
So yeah.
I just don't understand. This is correlation between in this plot. I see this correlation
Yes, yes, yes,
between
yes,
B5 and B4. And
yes.
what is the correlation PC1, PC2, PC3, PC4, and others? This correlation between what?
Okay, so basically it calculated the standard deviation. Okay, it calculated the standard deviation total 11 band, PC1 to PC11. It calculated the standard deviation value. Okay, and here you can see rotation n into k. N is the number of band and k is the number of column. In this time total 11 column we can get in here. Okay, it's showing the result for the standard deviation, and for each band we can get the result standard deviation. But when I see the plot, you can see I see the plot. So use at the SCR. Just we add the plot PCA. In this time, okay, in this time we can get the result look like that. You can see. So here we can get the variance about that. So in this time we can get the variance about the variance get the variance. So using this variance we can also predict. Suppose in this time using this variance value we can just simply predict from the other the first principal component, highlight the boundaries between the land use classes or special details. So in this time using the PCI value, how you can predict about that. So they are already use a function. So PCI, I take a variable PCI, principal component index PCI, and then use at the predict function. Predict. I want to predict using the Lancet. So Lancet image. So Lancet image. Just use at the Lancet. Okay. Call the Lancet imagery, and then I call the full data set. All of those full data set which are the PCA. Okay. And I also mention about the index. So use at the index is 1 and 2. 1, 2 means that 1 band, 2 band. So just I put this index look like that. And now you can see I just simply run that and simply show the plot. So plot I want to show the plot PCI and also make the PCI 1. So just use here this 1. So just add 1. So now it's showing about the what is the predict for the PCI 1 result. We can get this type of result. Very less vegetation about that. Suppose you want to put here the another band combinations. In this time it's showing the band 1 and 2. You can just put the other. Then it's showing about the according to this PCI value what is the condition it's predict for that from the PCI 1, 2, 3. Suppose I put here the PCI 2. In this time we can get the result look like that. Okay, for that according to this condition. So just put here the PCI 5. PCI 4. Okay, I put the index in here for that. So just I put here the PCI 2 and just click to the run. Okay, now I can hit you the result in here about that. So PCI 1. You get this everything. So in this time, this first principal component highlight the first. It's the first one is the first. Okay. So the first principal component highlight the boundaries between the land use classes or special details, which is the most common information among all wavelength. And it is the difficult to understand what the second principal component is highlight the. Let's try for the second. You can also see here the second. So use at the 2. Okay. Then it will showing the another information about the result we can easily get. Suppose in this time I show the PCI 2. So for PCI 2, just use at the principal component 2 PCI. I take a variable. In this variable, I just simply reclassify. So just use at the reclassify. Reclassify, just use at the PCI, then mention about the PCI2, and then I define here the C and make the negative INF 0 1 0. Then also mention about that I and F. Then use at the N8. Okay. So after the reclassify that, I show the result. So I want to show the two map in this frame. So use at the par and then use at the AMF row, and define here the column, one row, two column. So one row, two column I define it. So now, okay, so I run the code and check the result. Okay, it's okay. And after that, just simply display the results. So plot RGB. I also put RGB. So then simply call the Landsat. I simply simply copy the Landsat FCC, false color composite, and paste here. And now display the result for R equal 1. R equal 1. Then green equal 2. Then blue equal 3. And also put here the excess equal true. And then it put here the stress put here the stress equal lean. So all time same lean with the lowercase lean. That put here the Landsat. I put the title, suppose main, suppose Landsat FCC. Let's put the Landsat FCC. Okay, so after that, simply copy the same code from here again and paste. Then I mention the Landsat FCC and mention the band RGB, B R1, G is the 2, B is the 3, lean, main, Landsat false color composite. Okay, same. After that, I want to display the result about this. So use the plot, and then call the PC2. Use the legend false and add equal to. So now I simply just upload all of those things, run the code again. Okay, what is the problem? Okay, so it is a comma sign.
Oh, wow. This is Landsat.
Okay, and secondly, we can see it also show the result with all of those PC2 value also display in here. Mainly it's a land. Basically this is the red color identify about the vegetation, and it's identified there the lot of the barren land. You can see this is the barren land. Actually not a vegetation. Usually we can identify about
not vegetation. Yes.
So to learn more, so we can simply use the extension of the PCA in remote sensing, PCA principal component remote sensing. So this type of information we can use and then extract the different types of information from here. And finally, we can easily zoom in the result from here, as well as also just export, click on here, PDF or image, we can easily export from here.
Okay.
Okay, so this is the process.
For this method, we have some some accuracy, calculate some accuracy, or
yeah.
it's
So now we talk about that for the accuracy for the when I do for the, so basically it's showing the result only for the thresholding, how we can easily use the different types of thresholding. So now we apply to the k-means clustering. Okay, for the unsupervised, we use at the k-means clustering, and then make this type of map. Suppose using the k-means clustering, we can try to show you this type of map, how we can easily create for the LST map using the unsupervised classification. Okay, suppose you can see this is the NDVI map I already created. So now from this NDVI map, I just create this type of unsupervised classification map. As well as also you can see the another thing is that for the supervised classification. So and we already create about the all of suppose user accuracy, producer accuracy, okay, overall accuracy, kappa accuracy, all of those you can see. This is the formula about the kappa. So all of those accuracy, how we can easily calculate in the RStudio. Okay, you try to discuss one by one all of those code, then you can easily get the RStudio. And using the same code, you can easily make any types of land use, land cover classification. Just you have to download the satellite images from the Copernicus or other types of sources, and then use it in the RStudio. Okay, so let's go. Okay, so before starting that, we just take a break for the 5 minutes, then we'll start. Okay, for the 5-minute break.
okay. Okay, thank you.
Thank you.